So I'll just give you a walkthrough of what this project does. But before then, let me give you an ROS, right? ROS uses a pub submodel, which means nodes talk to each other using topics. Now, these topics have specific message type assigned to them, right? Now, for example, if one node is publishing an image to a topic, but the other node is expecting a string, now that's a problem, right? Of course, uh, if we have one or two packages, we can manually check what type of message that it is expecting or what dependency it is using. But when you have 10 or 15 or maybe 30, 40 packages, you can't manually go through all of them. You run them. I spoke to someone who has some experience with robotics, and he said, I just write my code, I push. If it works with the others, it works. Otherwise, we talk and call, we check what is going on, what is going wrong, and then we make the changes. So I thought, all right, why not use Dagger um, to analyze all these packages, right? So what my project, this is where ROS replay comes in. So it analyzes all the ROS packages that I've mentioned in a JSON object. It parses all the dependencies, right? It checks what publishers are present, what subscribers are present, what data types they both expect or they put forth, and then it flags these mismatches. And it also goes through the dependencies for all these packages, and then it creates a report that it can either email it to someone, or it can just show it on the terminal, right? So uh, this is how the structure looks like. So I have a run pipeline set up, the spin up function. So before I explain a little more about this, I'll just quickly run this in the background so that we can see an output of, oh, sorry. So if I run this pipeline, and now while I'm explaining, it'll go through the whole thing. We'll get an email report soon. So the spin up actually installs all the dependencies necessary for these ROS packages to be executed, right? It can also include Python and other pip dependencies that we have. Uh, the gatherer is responsible for cloning all the repositories that we've mentioned in the JSON dictionary, in the object. And then the watchtower is where the actual logic happens. It goes through every package. It understands what the subscribers are, what the publishers are, what type of messages they use. It goes through the dependencies, and then it creates a report for us. So I'll just quickly show you an example of somewhere where a mismatch does not happen, which would look like this. So we have runtime dependencies for these three packages: nav human communication, test robot control, and ROS turtlebot 3 test. Of course, these two are like test packages that I built just for the demo. And then so these are the dependencies that they have, the X's and the tick marks. So one thing to note here, the X's don't necessarily mean there is an error. It just means it is not being used right now. By that package. So this list is the dependency list, and then we have a subscriber and the publisher table, where so this is the topic that I showed you earlier in the image. The message type it expects is an image. This is the package that is publishing or subscribe to it, and so forth. And at the bottom, you'll see a message, no message type mismatch found, right? So here we are in the clear, but we have, oh, my bad. So I have this set here, email equals to true, which just sends us an email with the report. Oh,
and then in that table that you were showing us, I saw that there was no overlap in the different message types.
Yes.
In the case where you had I think like the two test packages on the right required
Mhm.
Turtle Sim or something like that. They both
Yes.
required Turtle Sim. Could it be that they need different versions of Turtle Sim and that could conflict at some stage?
Um, so these are the topics. So I mean, if we have a specific topic, you won't have versions of different topics by different packages, but you
Hmm.
might have different message types supported for different, I mean, for different packages. For example, if I have created my own package, which,
Hmm.
for example, it creates a new topic called, let's say, slash dagger slash group information,
Hmm.
right? Now it is my responsibility to understand what type of information is being published to that topic. The publisher can have it as simple as a JSON data, or maybe a pose or an image, right? So the subscriber will just understand what is the message type, and then use it. So there are these tools that ROS provides where you can visualize the whole thing like a mesh. But for that, you actually need to run the whole thing. While these packages are running, like while these nodes are running, you see the whole graph. But what if I'm just working on one package? And that was my case, right? I was just building one thing, and I had no idea what the others needed. So this is why I thought of ROS Replay. And I'm sorry, my screen stopped sharing for a few seconds,
Right,
but
Joe.
we can see here email sent successfully. So once we
Nice.
go over here, and this again, we can see there is no mismatch. But let's say I do want to make a mistake. I go here. This is one of the packages that I have. Let's say I change this pose to a JSON. If I
Hmm.
commit the changes, it is in the main branch, which is being used right now. So if I run this code again, it will take the latest code changes, right? It'll notice the difference where I'm publishing as a JSON, but I'm using it as a pose. There we will have a conflict. So it highlights that in the email. Um, and if I, yeah, sorry. Okay, so I have sent the email right now. So as we see in this, we see message type mismatches, topic, total one pose, published as JSON by this package, but is subscribed as pose by this package, right? So we see that there is an issue here which needs to be addressed, and that is what ROS Replay does. It also gives you a dependency table. It also gives you like a table view of the subscribers and publishers. But this is the bottom line. It just highlights what what is a mistake here and what um, needs to be changed.
Oh, that's nice.
Of course, this is built like with very limited experience, but I, I want to talk to others who are actually building bigger projects with ROS, right? And maybe this could be helpful for them because you can build C++ nodes and even in Python. So this just supports Python right now, and there is no AI included. So maybe I could use AI to understand uh, other best practices, and maybe there are these URDF files which describe a robot structure, like for example, an arm, like an or a camera's eye, and those things, right? So even that can be further processed. So I see scope here. Um, but with limited experience, I can only build smaller parts of this, and I want to keep on continuing to build this forward if that is going to be useful for the ROS community, of course.